Okay, for the next problem, we do have a transformation, an h and a k, that'll move our parabola away from the origin. So I'm using, when we went to those kinds of problems, this is page 742 out of the book. This is where I got everything I was using. Okay, so let's go back to the notes. Okay, here's how we know there's a left-right, up-down translation. It's because with our y squared, we have a plus minus. And we're going to do some solving steps, and you'll also see that we have a plus minus on the x axis. So we have with the y, we have an up-down vertical transformation, and with the x, we'll have a left-right. But we need to do a little bit of work to get it in standard form. Again, page 742, and standard form, when you have y minus k squared, looks like this. Y minus k squared equals 4p times x minus h. Okay? So what we're going to do is solve for y minus k squared, and I'm going to do that by multiplying the whole equation by 8. That gives me y plus 3 squared equals 8 times x plus 2. So that means that my h and k, we get the k is next to the y, and remember we're going to change the sign, and the h is next to the x. Also change the sign because we're taking both those numbers out of parentheses. Now we're going to work with the 8 and find out what p is, because it will show up as we identify the vertex, the focus, and so on. So 8 equals 4p. Do a little division, and it looks like p equals 2. All right. The vertex is going to be found at hk. So the x-coordinate is -2, and the y-coordinate is -3. Our focus is found at h plus p, comma, k. All right, so what happens when it's oriented towards y squared is our focus moves left and right by the p plus or minus where our transformation for the x was. So h is -2, p is 2, and k is -3. So this will turn into 0, -3. Okay, the directrix also has to do with our transformations and p. So it's oriented on the equation x equals h minus p. All right, so x equals h is -2, and p is +2, which gives x equals -4. So there's the equation of the line of the directrix, and the axis of symmetry is just at y equals k. Y equals -3. Okay, and we're done with that. All right, same idea. Oh, actually, this is a different idea. What we're doing is, notice we've got x squared, and we have a bunch of other terms. We are going to go to the standard form. It's the opposite of the last problem. Since we have x squared, and we should expect left-right transformations with all those other terms, our standard form is x minus h squared equals 4p times y minus k. Okay, just everything that we had in the last one switches with the x and y orientation. All right, so in order to make this look like x plus or minus something all squared, we're going to complete the square. On the x terms. So in order to complete the square, we isolate the x terms on one side of the equation. I'm going to move everything else over to the other side, and we'll get x squared plus 4x equals 8y minus 28. I'm going to ignore the y and the 28 on the other side for a moment, because I'm going to complete the square on the left-hand side. And remember, our formula for completing the square is b over 2 squared. b is 4. So I get 2 squared, which is 4. That means we're going to add 4 to both sides. On the left-hand side, I get x squared plus 4x plus 4. That I can rewrite. Now it's a perfect square trinomial. And on the right-hand side, I'm just going to do the math. Negative 28 plus 4 is negative 24. And remember, if I can factor a number out, it's going to look a lot like 4p on the right-hand side, so I'm going to do that next. 8y minus 3. Okay, so now this looks like standard form. And similar to the last problem, we're going to identify h and k. H equals negative 2, k equals positive 3, and we're going to use the 8 and find out what p is. Or p equals 8, looks like p equals 2. Okay, so when we have x squared translated off the xy axis by h and k, our vertexes at h and k, negative 2, positive 3. The focus is going to be at the ordered pair h, k plus p. H is negative 2, k is 3, and p is 2, which leads to the ordered pair negative 2, 5. The directrix is the equation y equals k minus p. Right, k is 3, p is 2, gives the equation y equals 1. And our axis of symmetry is going to be at x equals h. So the equation for our axis of symmetry is x equals negative 2. All right, done with that problem. I'll see you on the next example.